Good morning. I'll be starting the second week lecture. This lecture will contain basically different types of separator. Why do we separate? What are the different separation mechanism? Whether you have gravity settling technique, whether you have your emulsion treating technique, your heater treater technique. So different techniques are there. It will assist in separating. So whenever you are getting oil and water from wellbore, let's say this is my wellbore, wellhead is here. Okay, so you are getting oil plus water plus sand plus gas. Okay, now your customer will not take mixture of this fluid. So if you are a production engineer, so you have to separate oil, water, sand, gas. Water you are not selling, you have to dispose. Sand also you have to dispose locally. Okay, so your main product is actually oil and gas. Now oil will have mixture of component water and sand. So you have to remove water and sand. Water and sand you remove. Okay, remove. So there will be some other impurities such as H2S and other corrosive gases. So you have to remove that one also. From gas also same way, you have to remove actually water or moisture particle you have to remove. You have to remove other impurities, corrosive gases, etc. Then you send to your customer. Okay, so after removing everything, you send to customer. And water and sand, when you are getting on the surface, so you cannot dispose it everywhere wherever you like. So you have to remove hydrocarbon. Okay, then you dispose. And different disposal methods are there. We'll discuss later when we'll discuss details of water handling and sand handling later. Okay. Now whenever you are getting oil and gas on the surface, let's say this is wellhead. Okay, so from wellhead you are passing this fluid to a choke actually. So there will be choke. Okay, choke one valve actually. So choke when it is passing through the choke, so pressure is changing. When pressure is changing, your wellhead pressure and wellbore pressure or our fluid you are getting on the surface, the pressure will be something different. After choke, pressure will be something different. So you got reduced pressure. When you got reduced pressure, so it is possible that the temperature will be also going down because P V equals nRT formula is there. So if you are reducing pressure, temperature also can go down, volume can increase. Okay. Now you got separator. Let's say this is separator. Okay, so separator also there will be pressure drop. Okay, so pressure will be going down. Let's say initial pressure, let's say 1000 bar, 1000 psi. Okay, so after first stage separation, it is going to second stage. This is first stage or first separator. This is second separator. So pressure can be, let's say 500 psi. Okay. Now whenever you are getting any fluid from the wellbore, so you are getting mixture of oil, water, gas, sand, and because of high pressure, some gas will be dissolved in the liquid or oil. So when some gas is dissolved, when you are reducing pressure, you will get more gas coming out from your whatever fluid, wellbore fluid, you are getting the gas coming out. Another issue is that sometimes there will be emulsifying agent. Emulsion means like two immiscible fluid, like say oil and water. If you shake properly, oil and gas, so it will create lots of bubbles, and water bubble will be there in oil, or oil bubble will be there in water, and that water and oil bubble will be getting separated if we don't have any emulsifying agent. But if we have certain chemical which will assist in creating emulsion, then oil and water will not get separated. So then again you have to treat that one properly. So now complexity coming, you are changing temperature and pressure, so your more gas volatile component will be coming out, free gas will be coming out, your sand will get settled, water will be getting separated, but sometimes water will not get separated because you have emulsifying agent. Oil and water particle are forming mixtures which will not get separated easily, so that will be a problem. Sometimes oil or water will, especially oil, will create foam, so that foam will not get separated. So again, how big the separator should be? So it will be very small, very big, it will be horizontal, it will be vertical. So what sort of design should be there? What are the different dimensions should be there? So we'll discuss in the whole course. So issues are there, like if you have oil and water gas mixture, you have different pressure from different wellbore. Again, it will be coming from different wellbore also, maybe well 1, it will be well 2, maybe well 3, okay, from different wellbore. So, different wellbore will have different pressure also. So, wellbore 1 is having pressure 500 psi, wellbore will have 5000 psi, well 3 will have 5500 psi pressure. So, different pressure well fluid you are getting from different wellbore, and you have to mix up and you have to put in separator. Now, if you do not control this flow properly, what will happen? Low pressure well is there, high pressure well is there. So, high pressure fluid try to enter into low pressure wellbore. Okay. So, the complexity is there. So, you have to make certain arrangements so that high pressure fluid should not enter into the low pressure zone. Okay. And fluid will be going to separator and it will get separated. Now you got oil and gas mixture, I told, right? Oil, gas and water. Let us say oil and water mixture. So, oil water mixture if you have, and if you do not treat properly, so the oil particle will not separate from oil from water, or water particle will not get separated from oil. So, what will happen? This will be creating stable emulsion. So, you have to break the emulsion, then you have to create certain mechanisms, maybe some chemical, you have to put some electric field you have to put, so that emulsion that barrier will be broken and it will be creating bigger particle and it will get separated. So, what are the different types of separation mechanism? So, we will discuss. One way of separation is that you take certain amount of fluid, you allow certain time, so automatically water, oil and gas layer will be created. But if you have certain chemical which is not allowing to give that separation, then there is a problem. So, what will you do? So, you have to study whole mechanism, physics, chemistry, mathematics. So, then you have to understand how you will separate things properly, and how will you control pressure, how will you control temperature, how will you control flow, how will you control the level or flow rate. So, if you do not control the pressure, then it can create accident, or if there is any blockage, then if you do not know how much pressure is there or how much flow rate is there, how much temperature is there, so in that case your system may fail. Okay. Whenever you are separating, so you have to control the process. So, controlling process means like pressure control, pressure, temperature and flow rate and level. Okay. So, what are the things? This is control. Okay. So, whenever you have very high pressure or low pressure, you have to know that, then you have to take action whether you need to control pressure, or if there is any blockage, or is there any leakage in the system. If there is any leakage, then pressure can drop quickly, or if there is some blockage somewhere, things are not working because sand deposition, or maybe some failure somewhere in some valve, automatic safety valve. So, in that case pressure can rise in certain separator. So, if pressure is changing, then your separator system may not work, or whole piping system may not work, or it can be dangerous also. Okay. At the same time, temperature also you have to look at, because pressure and temperature is linked actually. If pressure is down by let us say 100 to 100 psi, maybe temperature will be down also, because pressure and temperature linked by Charles law, you can remember, PV equals nRT, right. And flow rate normally you do not control. If you control pressure, then normally flow rate also will be controlled in this relatively. And another thing is the level controller. Level controller I will discuss later. Level control means like in one separator system. Separator means pressure vessel. In pressure vessel, whenever fluid is getting separated, oil, water and gas, 3 layer normally it will be created. Gas means upper layer, very light, high, low density, and oil will be middle layer, and water will be lower layer, and further lower will be some sand deposition layer. Okay. So, let us say we are assuming 3 layers. So, now 3 layers we have in separator, 1, 2, 3, gas, oil, water, okay, and your fluid is entering here and fluid getting out. So, getting out means how to take the fluid out. So, gas, because of lighter density you take from the top, okay. So, this is gas line, and there will be oil line. Oil line means you are getting crude oil, but less gas and less water. Okay, and water line will be another. Now, if you do not maintain the level of water, how much water will be there in the inside separator, how much oil will be there inside separator, how much gas will be there in separator, there will be a problem. Why? Because water level, say gradually water level increasing. Okay, slowly increasing. So if water is entering to the oil outlet line, so oil outlet actually you are getting water instead of oil. Again, assume another situation when water level is very much down. Okay, if water level is very much down, again in water outlet line you are getting oil. So oil and water level you have to maintain properly. Okay, interface that area. If you do not maintain that one, then your system will not work. All right. So you have level controller. So you have to put some level controller here certain way. Okay, I'll discuss how this level controller will work later. Okay, these are called level controller. Level controller. Okay, so this will be automatic type like hydraulic, pneumatic, or these days these electronic level control system also there, because if you want to apply SCADA system, supervisory data acquisition system. So SCADA system is like you have surface production systems, everything working, and all the valves and flow measurement, temperature, everything will be connected to your master computer. So in your room, office room, you can observe which valve is working, which pressure is not working, where is the blockage, everything you can observe from your control room. So that is called SCADA system. So one master computer system will be controlling and giving all the responses in your control room, and there will be some automatic controller also. So if there is pressure slowly going up or temperature is going down, so then it will try to check other parameters also. If other somewhere blockage is there, then it will sense, okay, blockage is here, so you have to take immediate action. Sometimes it takes its automatic action also. Okay, so there is a supervisory data acquisition system and controlling system. This is called SCADA. Okay, so everywhere in industries like surface production systems, your pipeline systems, and your downstream system, people are using SCADA system, because manually you cannot go and you cannot operate everything. Okay, so you have electronic system. This electronic system will give signal to your control office, and you can check which parameter is changing and which is not desirable. So there will be lower limit, upper limit. So your level maybe 2 centimeter to 5 centimeter is the range. So if level is changing 2 to 1 centimeter or 5 to 10 centimeter somewhere, that means there is some fault in some cases. So you have to check that fault area. If you do not control that one, then there will be much more disastrous or much more problematic thing in future. Okay, so level control is important, and pressure, one is pressure control, one is pressure monitor. So you have to monitor, then you have to control. Okay, if you so all the things will be given to your data acquisition system, that computer, master computer system. Okay, now principle of separation. So why do you separate? Separate means like your customer will not buy oil if you have certain amount of solid content or certain amount of gas content or certain amount of water content. Okay, they will have some definitions. Okay, I do not want more than this much of moisture content or solid content, or gas will not be there normally, gas, because it will be normally atmospheric pressure. When it is atmospheric pressure, all volatile component will be going out anyway. When you separate, then after separation actually you are storing in a tank, storage tank. So when you are storing in storage tank, okay, okay. So when you will have storage tank after separation. So in storage tank actually it will be working the atmospheric pressure. Atmospheric pressure means normally your standard condition you assume like 14.7 psi, right, psia, and 60 degree Fahrenheit. So you must remember these parameters. Okay, so and normally in this condition you are storing, but if you are storing in Chennai, maybe temperature will be little bit different. If you are storing in Alaska, maybe temperature will be different, but normally standard condition is this one, 14.7 psi and 60 degree Fahrenheit, and volatile component will not be there in the surface condition. Okay, and you are sending to customer. So but water moisture content not allowed. So you have to measure that one, and you have to say, okay, I don't have moisture, or whatever you specify, I have less than that, or you specify this much of H2S or other component will be there, so I have less than that. So the purchasing or refineries, they will buy. If you do not maintain that one, then they will ask, okay, you rectify, then we will buy your product again. Okay, so principle of separation. So normally it will be centrifugal action will be there. Okay, centrifugal action, because of centrifugal action you are separating, or gravity separation. You have one separator and you are injecting fluid at very high velocity, right, at very high velocity. When at very high velocity fluid is moving, So, heavier particle will try to fall down, okay, and it will create one layer. And if you have any gaseous component anyway it will be going up, okay. So, because of the gravity separation and you are giving some centrifugal action also, so that way you are separating two phase actually, liquid and gas initially. Then you should have large settling section and you have to give enough time also. So, large settling section you have to give, and you have to maintain time within this separator. So, that you call retention time, how much time it will be staying inside the separator, the fluid, whatever fluid you are getting separated, okay. So, it is called retention time actually, retention, okay. Let us say you have very small vessel and fluid is entering and going out. So, the particle settlement time is not enough. So, in that case you will not get proper separation. So, if you give longer separation time, 1 month, 2 months, 4 months, it will be very good separation. Slowly oil particle will be moving up from water, and water particle in oil it will also moving down. So, separation will be very nice, life is beautiful. But you do not have so much luxury that you will get time that 1 month, 2 months, you will get only 5 minutes, 10 minutes, 15 minutes, 30 minutes. Within that time your fluid must get separated, okay. So, you have to design separator such a way that your flow velocity is this one, flow rate is this one, and your separator size diameter is certain XYZ, your length is this one. So, within that size you will get proper separation. So, that will be one optimization process actually. What will be the optimal flow rate or pressure, and how much pressure is going down, and how much time you are allowing. So, later we will do the calculation, separator sizing calculation, but these are parameters. Retention time one parameter, centrifugal action that is one parameter. Actually settling section, how big you are creating, you can create very big settling section, you can big pond you can create, or you can make very compact system. So, many times you will not have that much of luxury to create a very big area, for example offshore deck area, right. So, you have very compact area, there you have to separate, but on surface area many times you may have larger area, but again larger area means handling also very much difficult, larger machineries, okay. So, every time you have to optimize thing, okay. So, this is a design optimization problem, okay. This much of flow rate, what will be your separator time, how can you make a compact system and efficient system, okay. Your objective is to make compact, efficient, and your other criteria is that it must be cheaper, it must be working for longer time, longer duration, must be reliable, pressure, temperature, other thing should be within certain range, your pressure should not go very high or very low, temperature should not go also very high or low. So, all the parameters also, it is looking like a separator means a pressure vessel. So, pressure vessel you have to design what will be the thickness of the pressure vessel, thickness means like material, which material you will be selecting, or H2S is also coming. So, what material you are selecting, erosion, sand particle also there. So, erosion also possible. So, how will you then cleaning also issue is there. So, sand getting deposited, how will you clean it, right. You have leakage not allowed, rupturing not allowed, pressure, temperature control within must be within the control, and it will be within your cost limit also, production optimization. So, several things are there when you are designing or operating your system, okay. So, as a designer you have to consider many part, as a application engineer also you must know what are the parameters controlling your system efficiency performance. You are a production engineer and you cannot say okay I purchased this one and this is working. So, you also should know whether the sales people giving you product proper product, okay. Whenever you are calling to Vicar Hughes or Schlumberger or other big companies, so they will have a sales team. Normally their technical team initially not contact, they will sales team will contact. So, sales team will say sir buy this one, but as an engineer you should know whether that product or they are offering that is applicable for you or not, okay. Finally, you have to get optimized production. So, if you purchase wrong product, then your optimization production may not be optimally produced, right. Oil and gas should not be will not be getting optimally produced. So, in that case your profit will not get higher, okay. So, you have to give higher profit, less maintenance of the system whatever you purchased, and one system is not individually you are buying like separate only separator one, there will be several separators, there will be heater. So, it will be a complex system actually. So, everything is linked to each other. Only vertical separator, horizontal separator will be there, cyclone, hydrocyclone will be there, then will be scrubber will be there, then contactor column will be there. So, everything will be working in a synchronized way, okay. If your reservoir pressure is going down, So that means whole separator system may not work. Then how to handle that one? Okay, you may have to put an extra compressor to give the pressure, so the whole system will be untouched. You are just putting one extra compressor. Okay, but maybe a small pressure reduction is okay. So that also you have to consider. So as a production engineer, you should know all the part. Okay, you should know reservoir side also, actually reservoir side, artificial lifting side, production side, tubing flow performance, piping flow system, valve mechanism, separator system. Okay, so then you can understand whole thing and you can handle things properly. Okay, so whole course I will try to explain all these things. Okay, so this separator system, separator means pressure vessel, right? I said pressure vessel. Separator means pressure vessel, right? Separator. So why pressure vessel? Pressure means it can contain high pressure. Okay, although you are giving very high pressure, it will not get burst. So that way you design. So later we will see how to design the pressure vessel also. Okay. So you should have mist extractor. Mist extractor. So what is mist extractor? So when you have one separator and gas is there, okay, you see gas is coming out from top, right? So from gas, when a fluid is going horizontally and falling down inside separator, so high density fluid will fall down, low density fluid will try to move up. Low density means gas, right? Now some small particle also will try to move out with gas, but your gas line will not be capable of taking those liquids, right? Those can block the flow path. So you put one sieve sort of thing or one mesh, so that small liquid particle will fall down, it will not go with the liquid. So it will be like this, lots of mesh will be there, a haze section, a small section. Okay, when gas is moving there, so this small liquid particle will be touching this mesh. When it is touching the mesh, it will be sticking the mesh. So many liquid particle will be touching. So they will create bigger particle. When it is creating bigger particle, it fall down. Okay, so very minute tiny particle, it will try to move, but you try to create bigger particle. Bigger particle means density high, weight high, it will try to fall down. Okay. Okay, so that mist extractor purpose is that it will try to create bigger particle, liquid will fall down, and gas with less liquid, okay, relatively less, it will move up, move further. Okay, then it allows adequate control. So a control mechanism or whatever control mechanism is there, so the control mechanism must be part of the whole system. Okay, so one is controlling, one is monitoring also. So temperature, pressure, flow rate, everything you will monitor, and when you see parameter changing, you take action. There will be these days solenoid valve. I think you may have heard the term solenoid valve. Solenoid valve, actually using electrical control, you change valve opening and closing. Okay, you want to increase 10%, decrease 20%. So that you can use using your control mechanism, electrical control. So manually you don't have to go and in the field and you have to work there. So your electronic system will take action. So SCADA is designed for that only, it's unmanned operation. So there will be no manpower there. So you are working in the control room only, okay, and you are observing things. Okay. And primary function of separator. So primary function of separator, now you see this 4 phases you are separating, and you are handling oil separately, gas separately, water separately, and water and sand you are removing all hydrocarbon particle and you are disposing. Okay, because oil and water, it is not giving you money. So whenever you are producing oil and gas, so your main tendency should be to reduce oil and gas production as much as possible, although not possible 100% to stop everything, but if you can minimize, that is better, because on the surface you have to handle it, you have to remove hydrocarbon and you have to dispose. So different issues are there, and if you are to dispose here and randomly, then environmental agencies will be there, so they will stop your activity. Okay, so to avoid all these political and environmental issues, so you have to remove hydrocarbon, maybe you have to inject water, or you have to manage certain way so that sand and water can be disposed without harming your environment. And you produce such a way that you get less amount of sand, less amount of water. That's why sand control mechanism I already told. Sand control mechanism is there, reduce sand, and your productivity rate also you take such a way so that water coning should not be there, so that you are getting only water instead of oil. Okay. So, your production rate also should be optimized, your sand control mechanism should be working. So, in that way you are reducing both and you are getting oil and gas more, but anyway you cannot make 0 water, 0 sand. Okay. You will get certain amount, then you have to handle on the surface.